Hello, class. Welcome to lesson 11.5, Polynomial Long Division. Now, I'm sure you're already thinking about how lovely this is going to be, but the foundation is really just basic long division. We're eventually going to be taking things like x plus 3 and trying to divide them into polynomials like 4x to the third plus 8x squared minus 6x plus 2. Now, I know that looks a little intimidating, but if you have the basic foundation of what division is, maybe something like 3 divided into 1,700, I don't know, 61. If we know how to do this by long division, we can use what we call an algorithm. It's just a pattern that repeats over and over and over again in order to divide this. So let's refresh our memories and we'll take specific notes on this when we actually set up a lesson 11.5. So guys, the first step to any long division is to divide. What we do is we take that 17 and we divide it by 3, and we know it goes in 5 times. Now, this is usually what people think of next. They think they have to subtract. However, you skipped over the key step of multiply. Don't you have to multiply that 5 back with that 3? So 5 times 3 is 15, and now we actually have to subtract. So what we do is we subtract, and then we bring down, and now we repeat. And this is what the algorithm is. Step 1, divide. 3 goes into 26 8 times. Now we multiply back through the divisor of 3. Then we subtract, and then we bring down. So 3 goes into 21 7 times, and when we remultiply back, there is no remainder. So, because that's the division algorithm, we are going to take that and apply that to this long division. So, please, I'm going to pause the video. Please get yourself set up with lesson 11.5, Polynomial Long Division. All right, class, I hope you're ready for this. So what we're going to do on lesson 11.5, Polynomial Long Division, Part 1. I have separated this into 2 parts because I'm not going to throw this all at you at one day. Maybe make it more manageable pieces for you. All right, so you guys, what we're going to review is some basic elementary school long division. This is going to form the division algorithm that I was just talking about over here. Now the whole point is, if you can learn this, what we can do is easily get to the longer polynomial long divisions. Now, before we review, let's go over some basic vocabulary. Now, you guys, that's your division right there. So the number that you're actually dividing with is called the divisor. Do you remember what the number underneath the division symbol is called? Maybe 50-50. All right, so guys, that's called a dividend. So you always take the dividend and you divide it by the divisor, and the final result of the division is called the quotient. You should be most comfortable with that word. If anybody says, what's the quotient of this and that, that means you're dividing and looking for that final outcome. All right, so you guys, what we're going to do is this long division based on just basic elementary principles and develop our division algorithm. So step 1, take that divisor and actually divide it into the dividend. Obviously 5 does not divide into 3, so 34 divided by 5 is 6. So step 1 is to divide. Now, step 1 is to divide. Step 2, however, this is the one that most people forget. What you do is you take the beginning part of that quotient and you remultiply it back through the divisor. So 6 times 5 is 30. So we divide, then we multiply, and now we're ready for the subtraction. Please remember that this is always going to be a sign change. especially when we have multiple terms down here. That's going to do a whole bunch of keep, change kind of things. All right, so when we subtract, we get 4. So we divide, we multiply, we subtract. In order to continue, we have to bring down the next number. And this is what makes it an algorithm, something that repeats over and over and over again. Step 5 is just to repeat the process until there's nothing left to bring down. So, looking through here, step 1, 48 divided by 5 is 9. 9 times 5 when we multiply is 45. We now subtract and bring down. So there's nothing left to bring down to this final multiplication there, or that final division right there. 5 goes into 37 7 times, but this case, there is a remainder left over of 2. So what we like to do is any remainder always gets written over the divisor. So any remainder is written over the divisor. So our final answer over here is 697 as the quotient with 2 over 5 as the remainder. And that, my friends, is long division. Now we're about to use that in order to get to some basic polynomial long division. But let's have a stop over here and see if we can make sure that algorithm works for us. All right, so step 1 is to divide. 12 divided by 6 is 2. Divide, multiply, subtract, bring down. Now, 6 goes into 7 once. Divide, 1 times 6, multiply, subtract, bring down. 6 goes into 12 twice, multiply, subtract, nothing left to bring down. All right, there's no remainder here, and our final quotient is just 212. Now, I already can predict that we're going to have a remainder over here because obviously that doesn't end in a 5 or a 0, so it will not divide nicely by 5. But if we proceed with our division algorithm, divide, one more, up to 7 right there, pardon me. All right, multiply, subtract, bring down. All right, now we're going to repeat. 5 divides into 31 6 times. Divide, multiply, subtract, bring down. 5 goes into 14 twice. Divide, multiply, subtract, and there's nothing left to bring down, so that's just simply our remainder. Now what we're going to learn is that we're going to be rewriting a lot of these things in the quotient plus remainder over divisor form. This is generally how you write things. So what we have here is 762 plus a remainder of 4 over 5. Now obviously with elementary stuff, a lot of times we can take these mixed numbers and just squish them all together, and that's technically why we're allowed to write it that way. All right, so are you guys ready for your first journey into the long division that we're going to be looking for? All right, so what we've got here is the basics of polynomial long division. Guys, this is 3a and this is 3b. If you notice, I have the exact same problem here. So what I want to do is actually divide this by factoring first. This is something that's actually going to be huge when we get to Unit 12 on what we call rational expressions, but it's very simple. What I'm going to do right here is I am going to factor this, and then I'm going to cancel some like terms. This is just a simple trinomial. So it's really just what multiplies out to 40 and divides or add or subtracts out to 3. So obviously x times x is x squared, and 5 times 8 is 40. Different signs, -8, +5. Now, here's the thing, guys. What you have here is that being divided by the divisor of x minus 8. So what I've done is factored in, and now I'm looking to cancel like terms. Because this is a product, I can just cancel x minus 8 with x minus 8, and the final quotient after the division is just x plus 5. Now, this kind of thing will only work if something is factorable. However, not everything is going to be factorable, so you're going to have to form another way to divide. And that, my friends, is polynomial long division. Now, we're going to take more specific notes on this on the next page, but here's really the setup. What we do is we take our divisor of x minus 8, and we are going to divide it into the dividend of x squared minus 3x minus 40. Now look, I know that this looks very intimidating, but you have to just learn the algorithm. The minute you do that, it makes it 1,000 times easier. So here it is. Step 1, if you look above, is to divide. Because what you do is you take the first term of the divisor and you divide it by the first term of the dividend. I actually like to do that off to the side. X squared divided by x is just x. So that's the division. Now, step 2, this is huge. This is the multiply. This is when you take that part of the quotient and multiply it back through by the divisor. But, guys, this is 2 terms, so it's going to be a distribution through that. X times x is x squared, and x times -8 is -8x. All right, so what we've done is we've performed the first 2 steps of the division. Step 1, we divided. Step number 2, we multiplied back through, and here's the tricky part. Guys, now we have to subtract, but it's more than just subtracting this. You're subtracting this whole thing. So if you're subtracting, it's really just a keep, change the whole thing. If you're subtracting, this is going to be a negative, and that's going to be a positive. A subtraction is just the opposite of. Now, just like normal, it's supposed to cancel out if you've done this correctly. Those eliminate themselves, and -3x and +8x give us a +5x minus 40. Now, let's walk ourselves through that again. We divided the first term of the dividend divided by the first term of the divider, so that's the division. It goes in x times. Then we multiplied by distribution. Now we subtracted, and we brought down. And this is where we now repeat the algorithm. Take the first term of 5x and divide it by the first term of the divisor, and it goes in 5 times. So it's a +5 right there. Now we divide it. Now we multiply. 5 times x and 5 times -8. Now the subtraction, people. I'm just going to change the signs because the subtraction is a sign change. They both eliminate themselves, and now there is a remainder of 0. Now, I don't know if you guys recall, these are the exact same problems. When we did this division here, we ended up with a quotient of x plus 5, and when we did this long division, we also got a quotient of x plus 5. So we've done that correctly. So right there in a nutshell is what the polynomial long division is going to look like. So why don't you turn the page over, and we're going to take a look at what the notes for this are. We've got right here the procedure for polynomial long division. And what I want to do is I want to point out the actual algorithm here. Okay, are you ready for this? So it was 5 steps if you remember. So we're going to get to all of these steps and read through this together in a minute. But the thing is here, set up the division. Make sure you have your divisor ready to be divided into the dividend. Then we divide. Now what we talked about, people, was it's dividing the leading terms. What you do is you take the first term of the dividend and you divide it by the first term of the divisor. Like I said, I always do that off to the side. I don't really trust doing this in my head. So 2x to the fourth divided by 2x is literally just x to the third. And that gets rewritten above. So that's the divide step. Now, the second step is the multiply. So right over here, the next step is the multiply. But what we do there, it's really now a distribution. So x to the third times 2x minus 3, that multiplies back to 2x to the fourth minus 3x to the third. Now do you see that's where I'm looking right there? 2x to the fourth minus 3x to the third. So that's just the distribution part. Now this is honestly the trickiest part to keep track of. You guys have to subtract. Now, I've done this throughout my notes because I don't want to pollute the notes. However, if I was doing this for real, I wouldn't actually write it like this. What this is showing is subtract the whole thing, which means these both need to be negated. Because right now, 2x to the fourth and 2x to the fourth is actually 4x to the fourth. And isn't 9x to the third and negative 3x to the third negative 12x to the third? But that's not what it's going to get us because we're subtracting. It's a sign change. This is going to be a minus, and that's going to become a plus. Now, those eliminate themselves, and negative 9 and positive 3 is what gives us the 6x to the third. So we divided, then we multiplied back, then we subtracted, and now we have to bring down. And then the whole algorithm is going to repeat itself. So understand where we are at in this problem. So all we have right now is this negative 6x to the third and the positive 21x squared. So what we do is we take the first term and we divide it by the first term of that divisor. And that gets me negative 3x squared. And that starts building the quotients. Now, this is really the last part we'll go through before we actually start trying some examples. But what you have here is this is now going to be remultiplied. Negative 3x squared times 2x is negative 6x to the third. And a negative times a negative gets me a positive 9x squared. When you now go through and subtract those, that cancels, and 21x squared and negative 9x squared is 12x squared. And then you would bring down and repeat the whole algorithm. Now, the final step